August 18, 1944, near Falaise, France. German Field Marshal Walter Model faced a battlefield reality that was becoming increasingly difficult to explain. For weeks, Allied forces had been advancing across Normandy. German units fought stubbornly, inflicting losses wherever possible. Tanks were knocked out, trucks were abandoned, artillery pieces were damaged. Roads were littered with wrecked vehicles. Yet something strange kept happening. American armored formations seemed to recover from losses with remarkable speed. A tank reported destroyed 1 week might reappear days later. Vehicles disabled during a battle somehow returned to service. Entire formations continued operating, despite mechanical breakdowns, combat damage, and the exhausting demands of constant movement. To German commanders, this was deeply frustrating. In modern warfare, equipment losses were supposed to accumulate. Every destroyed vehicle should gradually weaken an army. Every mechanical failure should reduce combat effectiveness. Over time, maintenance problems alone could cripple even the strongest force. But the Americans appeared to be playing by different rules. Behind the front lines, a hidden army was at work. Recovery crews moved onto battlefields after fighting ended. Heavy wreckers pulled damaged vehicles from ditches and shell craters. Mobile workshops repaired engines, transmissions, suspensions, and weapon systems. Spare parts flowed forward through a vast logistics network, stretching all the way back to factories in the United States. The result was extraordinary. Many vehicles that German troops considered destroyed were merely damaged. Many tanks that appeared lost were repaired and returned to action. Instead of accepting losses, the Americans built an entire system dedicated to reversing them. It was one of the least glamorous aspects of the war, but it became one of the most important, because the secret to sustaining an army was not simply building equipment. It was keeping that equipment alive, long after it should have disappeared from the battlefield. By the Second World War, armies had become increasingly dependent on machines. Tanks spearheaded offensives. Trucks carried fuel, ammunition, and food. Half-tracks transported infantry. Artillery tractors hauled heavy guns across difficult terrain. Every major operation relied on thousands of vehicles working together as a single system. But machines had a weakness. They broke down. Contrary to popular belief, many military vehicles were not removed from action by enemy fire alone. Long marches, poor road conditions, mud, dust, extreme temperatures, and simple wear and tear often caused as many problems as combat itself. Engines overheated, tracks snapped, gearboxes failed, suspensions cracked under constant strain. The problem grew worse during large offensives. A tank advancing hundreds of miles could suffer countless mechanical issues, even if it never encountered the enemy. Every additional mile increased maintenance requirements. Every day of operation placed more stress on critical components. Military planners understood this reality well. A vehicle that could not move was often just as ineffective as one destroyed in battle. If breakdowns accumulated faster than repairs could be completed, an army's operational strength would gradually erode. This challenge affected every major combatant. German formations on the Eastern Front struggled to maintain vehicles across vast distances. Soviet units frequently faced maintenance difficulties during rapid offensives. Even highly mechanized Allied forces experienced constant mechanical problems. The difference lay in how those problems were addressed. Many armies viewed maintenance primarily as a support function. The Americans increasingly treated it as a combat multiplier. Keeping equipment operational became an essential part of battlefield planning rather than an afterthought. This approach proved particularly important because American strategy relied heavily on mobility. Fast-moving offensives demanded reliable vehicles. Reliable vehicles required efficient repair systems. As the war progressed, U.S. commanders recognized that replacing damaged equipment from factories alone would never be enough. What they needed was a method of recovering, repairing, and returning vehicles to service as quickly as possible. That requirement would lead to one of the most sophisticated maintenance systems fielded by any army during the war. Long before American forces landed in North Africa or Normandy, U.S. military planners had begun studying a critical question: what happens after a vehicle breaks down? The answer shaped an entire doctrine. Rather than treating damaged equipment as expendable, the U.S. Army developed a maintenance system designed to recover and repair as much equipment as possible. This philosophy became especially important as the Army expanded into a highly mechanized force, dependent on thousands of tanks, trucks, jeeps, half-tracks, and artillery vehicles. Responsibility for much of this work fell to the U.S. Army Ordnance Department. The Ordnance Department was far more than a supplier of weapons and ammunition. It also managed maintenance, repairs, spare parts distribution, technical training, and vehicle recovery operations. Specialized units were created specifically to keep combat equipment functioning under battlefield conditions. The system operated in layers. Minor repairs were performed close to the front by unit mechanics. More complicated problems were handled by dedicated maintenance companies and battalion workshops. Severe damage could result in equipment being transferred to larger repair facilities farther from the fighting. This structure ensured that repairs occurred at the appropriate level without overwhelming any single organization. Recovery vehicles became equally important. Heavy wreckers and armored recovery vehicles moved damaged tanks and trucks away from combat zones before they could be abandoned or destroyed. Once recovered, mechanics assessed whether equipment could be repaired, rebuilt, or salvaged for parts. Standardization played a crucial role. American vehicles such as the M4 Sherman, GMC CCKW truck, and Willys Jeep were produced in large numbers, using standardized components. Spare parts could often be exchanged quickly, without extensive modification. Mechanics became familiar with common systems, allowing repairs to proceed faster and more efficiently. The result was a doctrine focused on preservation rather than replacement. But doctrines alone do not win wars. The real test came when maintenance units followed advancing armies into combat zones, where they transformed fields, barns, and roadside depots into temporary factories capable of bringing damaged machines back to life. The true strength of the American repair system was not found in manuals or organizational charts. It was found a few miles behind the front line. As Allied forces advanced through North Africa, Italy, France, Belgium, and eventually Germany, mobile maintenance units moved with them. These units were designed to operate close enough to support combat formations, while remaining far enough from the front to conduct extensive repair work. Their workshops could appear almost anywhere: a field outside a French village, an abandoned warehouse, a damaged factory. Even a roadside clearing could become a repair center within hours. Trucks arrived carrying tools, spare parts, generators, welding equipment, and specialized mechanics trained to handle everything from engines to radio systems. The workload was relentless. After major battles, recovery teams searched battlefields for damaged vehicles. Tanks stuck in mud, trucks damaged by artillery fragments, and vehicles suffering mechanical failures were towed away for inspection. What appeared to be a total loss often turned out to be repairable. The numbers were impressive. See, throughout the war, American maintenance organizations returned vast quantities of equipment to service that otherwise would have been written off. Engines were rebuilt. Transmissions were replaced, damaged armor was repaired. Electrical systems were restored. For frontline commanders, this created a valuable advantage. A repaired tank could return to combat far faster than a replacement vehicle could be shipped from the United States. Repairing equipment conserved shipping space, reduced logistical strain, and preserved combat strength. This capability became especially important after the Normandy breakout in 1944. As American forces raced across France, supply lines stretched hundreds of miles. Delivering completely new vehicles to every unit would have been difficult. Repairing existing equipment close to the battlefield proved far more efficient. To German observers, the results could be confusing. Equipment losses that appeared significant often failed to produce lasting effects. Damaged vehicles disappeared from the battlefield only to return later. And that raised an uncomfortable question for German generals. How do you weaken an enemy whose equipment keeps coming back? From the German perspective, the American repair system created a problem that was both operational and psychological. German commanders understood attrition. Throughout military history, one of the primary ways to defeat an army was to gradually reduce its strength. Destroy enough tanks, enough trucks, enough artillery pieces, and eventually the enemy's ability to fight would collapse. But American maintenance units interfered with that process. A tank knocked out by mechanical failure was not necessarily lost. A truck damaged by shell fragments might be back on the road within days. Even vehicles suffering significant damage could often be recovered and rebuilt. This reduced the long-term impact of battlefield losses. German units frequently achieved tactical successes, destroying or damaging enemy equipment during combat. Yet, the expected reduction in Allied strength often failed to materialize. Vehicles disappeared from the battlefield only to reappear after repairs were completed. The contrast became increasingly visible as the war progressed. Germany struggled with its own maintenance challenges. The growing diversity of German vehicles complicated logistics. Different models required different parts, tools, and expertise. Wartime shortages made replacement components increasingly difficult to obtain. Allied bombing campaigns worsened the situation by disrupting transportation networks and industrial production. Meanwhile, American forces benefited from standardization, abundant spare parts, and a maintenance shop built around rapid recovery. The result was a form of operational resilience. When German commanders assessed Allied strength, they could not simply count vehicles destroyed in battle. Many of those losses were temporary. The actual reduction in combat power was often far smaller than appearances suggested. This reality became particularly frustrating during the campaigns of 1944 and 1945. As Allied armies pushed toward Germany, American formations continued to maintain impressive levels of operational readiness. Despite the enormous demands of modern mechanized warfare, the battlefield seemed to absorb losses without slowing down. For German generals, the lesson became increasingly clear. They were not only fighting tanks, trucks, and artillery. They were fighting an entire maintenance system designed to ensure those machines remained in the war. And behind that system stood something even more powerful: the industrial network, supplying every repair with the parts it needed. A mobile repair unit was only as effective as the parts available to it. No mechanic, regardless of skill, could rebuild an engine without replacement components. No workshop could repair transmissions, radios, suspensions, or weapon systems if spare parts failed to arrive. This is where American industrial power became decisive. Behind every repair depot in France stood an enormous supply chain stretching across the Atlantic Ocean. Factories throughout the United States produced not only complete vehicles, but also millions of individual components: engines, gearboxes, track links, tires, bearings, electrical equipment, and countless other parts flowed into a global logistics network. The scale was unprecedented. American industry embraced mass production and standardization to a degree rarely seen before. Vehicles such as the M4 Sherman, GMC CCKW, and Willys MB Jeep were built using components that could be replaced quickly and efficiently. Maintenance units did not need to fabricate parts from scratch. They simply installed new ones. Supply depots throughout Britain and later continental Europe maintained vast inventories of replacement equipment. Ships crossing the Atlantic carried not only weapons and fuel, but also mountains of spare parts intended specifically for maintenance operations. This created a powerful feedback loop. The more vehicles remained operational, the more combat power Allied commanders retained. The more combat power they retained, the faster offensives could continue. Every successful repair effectively multiplied the value of existing equipment. German forces struggled to replicate this system. By the later years of the war, industrial production faced growing pressure from Allied bombing campaigns, resource shortages, and transportation disruptions. Spare parts became increasingly scarce. Repair times lengthened. Many damaged vehicles were cannibalized to keep others running. The Americans faced maintenance problems as well. The difference was that they possessed the industrial depth to solve them, and that industrial depth transformed repair units from simple support organizations into strategic assets capable of sustaining entire armies. By 1945, the cumulative effect was impossible to ignore. American power wasn't merely being produced. It was being constantly renewed. When historians discuss the Allied victory in World War II, they often focus on famous battles, powerful weapons, and celebrated commanders. Yet some of the most important factors behind victory operated far from the spotlight. American mobile repair units were among them. They ensured that damaged vehicles did not automatically become permanent losses. They transformed wrecked tanks into operational fighting vehicles, broken trucks into functioning supply carriers, and damaged equipment into usable combat power. In doing so, they changed the mathematics of war. For German commanders, every destroyed vehicle was supposed to weaken the enemy, but the American maintenance system repeatedly reduced the effectiveness of that strategy. Equipment that seemed lost often returned. Units that should have been depleted remained operational. The achievement was not the result of mechanics alone. It depended on doctrine, training, recovery teams, spare parts logistics, industrial production, transportation networks, and organizational discipline. Together, these elements formed a system capable of sustaining mechanized warfare on a scale few nations could match. By the final year of the war, many German generals found themselves confronting an uncomfortable reality. Defeating American forces required more than destroying their equipment. It required overcoming the vast machinery that repaired it. And that proved far more difficult, because one of America's greatest weapons in World War II was not a tank, an aircraft, or an artillery piece. It was an army that had learned how to repair itself